Okay, the last little bit, the periodic table. Mendeleev in 1869, and a year later, Sir Lothar Meyer, who got uh, some of the credit as well in 1870, kind of they both independently created a periodic table of some sort. You don't really ever need to know this, but what they noticed is they started putting things in order of their masses. I'm going to take every single element that I have and order it in terms of its mass, and you just kind of put them all in a line, and you just keep going. But what they noticed is 1, 2, 3, 4, 5, 6, 7, 8, 9. Neon and helium had the same properties. So after 8, the ninth one had the same properties as helium. And then they did it again. 1 or 1, 2, 3, 4, 5, 6, 7, 8, 9. Every eighth element, right? So 1, 2, 3, 4, 5, 6, 7, and the eighth one repeated. Count 8 and repeats with neon. Counts 8 and repeats with argon. Count 8 and repeat with krypton. Every 8, they had something that repeated. And so what they simply did is instead of putting them all in a line, they said, well, if these behave the same, we're going to stack them on top of one another. And that's what they did. And that's how the modern periodic table formed. So the modern periodic table basically took into account that all of the things in the same group, and we're going to get into this, have the same properties. And that's just kind of how the periodic table actually formed. So elements and symbols, these things have kind of been generated throughout history, and they've come from various sources. So uranium comes from the planet Uranus, titanium from mythology, chlorine, iodine from Greek words representing the colors when they discovered them. Magnesium comes from a certain mineral where it's found. And then some of the more modern ones, like californium, come from California or Berkeley Labs, where it was discovered. In fact, there's berkelium now. Some are named after people, curium, copernicum, and all that. But so those names and those symbols, typically now when they create an element or they have an element, it's going to be 2 letters, a capital and a lowercase. And we have this variety of chemical symbols all associated. What you are going to notice is some of these don't line up. So aluminum is Al, argon is Ar. A couple of them don't line up. Gold is Au because it comes from the Latin aurum. Lead comes from plumbum. Mercury, okay, geranium, silver, natrium for sodium, so tin, stannum. So some of them are a little bit off, and just have to recognize the ones that are really kind of important to recognize are just their symbols don't match their words. Potassium, sodium, silver, gold, lead. I mean, really all of these, but yeah, mercury, tin. Just make sure you recognize that those don't match the chemical symbol in the name, okay? Because they used to, but not anymore. Okay. So groups, periods, and group names, okay? So here is a periodic table. What you're going to notice along the top is a series of numbers. So 1, 2, 3, 4, and in fact, we changed those a little bit. It used to be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. What I'm really interested in is the ones place. I don't really care. I'm going to talk about these in terms of 1, 2, 3, 4, 5, 6, 7, and 8. We are going to talk about those groups. 13 is really group 3. The ones that are highlighted, those are the ones that we're going to spend most of our time on. Okay, so a couple of things. Down is going to be called a group, okay? And a group will have similar chemical properties. Okay, that's really important to know. Everything in group 18, everything in group 18 is going to behave similarly. These are all the noble gases. They're all inert, they don't react, they're all gases. So everything here in this group, because they're all in the same column, all behave very similarly. They have similar chemical properties. Know that. Group, group, group. I'm going to use the term group a bunch. Group is the stack, the column, okay? From left to right, this is less important to know, but it is important to know. We call this a period, okay? And that is also going to be numbered 1, 2, 3, 4, 5, 6, 7, and we'll talk about that group below, or those two below in a little bit, okay? In fact, I will talk about it now. These go in here. Okay, so this goes in here and essentially just spreads out the periodic table. Okay, making this 6 and this 7. So it just kind of sticks in there and extends the periodic table. And we can fit it on one sheet of paper if we do it like this, though. Okay, a couple of names of groups I'm going to highlight. Let's see here. So we're going to start with group 1. Group 1 is known as the alkali metals. Okay, alkali metals, and I'm going to refer to some of these. I'll show you the important ones. Alkali, these are important to know. Group 2 is known as the alkali earth. Alkali earth metals. All the way down here, group 18 is the noble gases. They're very inert. And this next one is super important. This is one that this is the one that is most often called by its name, more than anything else. Group 17 with fluorine, chlorine, hydrogen, or bromine, iodine. This is known as the halogens. The next one, the one next to it, you don't need to know it really. The first two and the last two are the most important, but the one next to it, just because I know it. So group 16 is known as the chalcogens. Sorry, I can spell this so you can actually read it. Group 16 is known as the chalcogens. Pathogens, and the next couple have one as well. Here's another interesting one. Don't really need to know this either, but kind of neat. Cu, this group right here, we're not going to include the bottom row because they're really not, they're not stable at all. But this group right here, copper, silver, and gold, these are known as the coinage metals, right? Because they're all coinage metals. Okay. All right, good. So that's the different groups. Down a group, that's the most important thing. They're going to share the same properties. No, 1, 2, 17, and 18, those are really important to know. Turns out that the periodic table is kind of broken into two sides. The left-hand side, all the blue ones here are metals. They're going to behave similarly. Metals, and we can get into this as well. In fact, I think I do a little bit, but metals are going to be conductive. Electricity passes through them easily. They have a luster. So they're very shiny, okay? They're malleable. And other metal type things. If you think a piece of iron or you think a piece of copper, it's very malleable. You can bend it. It's got luster. It's conductive, right? You could turn it into a wire, those types of things. So all of the blue ones, what you're going to notice is there is a little bit of a staircase over here, okay? And that's kind of be the important thing. And we're going to have this recognize that between boron and aluminum is clearly a metal. And then we're just going to go down. Silicon is not. This right here is the division point for, we're going to create a little staircase there between metals and non-metals. So the left-hand side of that staircase are the metals, the right-hand side are the non-metals, and the upper right-hand side. What you will notice is that hydrogen over here, hydrogen kind of behaves like on its own, it's considered a non-metal, right? Think about hydrogen gas, you don't really consider it a metal. Non-metals, on the other hand, are all the yellow ones. The non-metals are not conductive, or they're insulators. They are brittle, so they're not malleable, and they're dull, right? So they don't have much. I guess I should have done those in the other order, but they're dull. They're just kind of, carbon, which would be like charcoal, for example, right? So it's just kind of dull. Phosphorus, they're just kind of powdery looking. They don't really look like they have any sheen. The ones on the staircase, boron, silicon, germanium, basically everything on the staircase except for aluminum is called a metalloid. So it's semi-conductive, and it has a little bit of a shine, and it is somewhat malleable, but kind of also brittle. Okay, so it's kind of in between those two. Metals on the left, non-metals on the right, and then metalloids on the staircase, minus aluminum, which is clearly a metal. Okay. Okay. So that gets us into the periodic table of the elements. And in class, we are going to use this blank periodic table, and we're going to talk about a lot of it. In fact, some of that's wrong, but we're going to take a look. But we're going to talk about this as a whole, and kind of make some determinations and kind of look at this. So please make sure you have a copy of this so we can kind of work through it together. Okay, great. So that is the end of chapter 3. I'm going to probably put a different periodic table on the back of this, but that should do it. Okay.